And welcome everybody to our third daily space weather video of the day. We've got significant electron flux going on here. We've got basically an electron storm, very high levels, and some significant charging hazards for satellites. This is showing you the most likely places for GPS errors. It's our total electron content forecast. And we're going to be seeing a lot of GPS errors across the planet today until these electron levels subside. So what you're looking at there is the free electrons in the plasma sphere in the lower Van Allen belt primarily. Your GPS satellite's located at about 12,500 miles of altitude. And here are these charging hazards. These are caused by the high energy relativistic electrons. They can get all the way into the internal parts of satellites, causing them to charge up internally. The lower level energy state electrons are capable of producing the surface charging. We don't see any of that. We're seeing the greater than 2 mega electron volt electron flux causing quite a bit of charging hazards around a large portion of the planet, especially the southern hemisphere where it's summertime. So here you can see these high levels of electron flux, the highest we've actually seen for several months. That's the one-year chart from Solon.info. And here's a 3-day graph. We've been remaining in warning territory here, and we can expect another day or two of very high levels of electron flux, communication breakdowns, and so on. It's not China, it's not Russia, okay? It's electrons that are causing the communications breakdowns. It's not hacking or EMP attacks or directed energy weapons. Next, looking at the forecast model, I would anticipate this is going to stay high for a couple more days yet. But keep in mind there is a coronal mass ejection strike forecasted to show up on the 10th. That will most likely affect things. Next, we're going to show the ionosphere layer. Make sure you watch our previous videos if you didn't know about the coronal mass ejection strike forecasted. Here comes the ionosphere. The F layer is located at about 300 kilometers of altitude. Here's that slice in vibrational frequency. It's the F layer of the ionosphere. This data is courtesy of Australian Government Bureau of Meteorology. And it's actually looking not so anomalous at the moment. Here's the anomalygram showing anomaly in megahertz from the 30-day median. And again, not all that anomalous on this past day. So we'll let this play through, then we'll show you the latest image. There's the latest image at 11:15 Universal Time. On the ionogram, there's the latest image, 11:15 Universal Time anomalygram. And let's continue on through additional bonus features. First, welcome to the Neo Renaissance, folks. Congratulations on realizing the channel exists. We are in the process of writing a publication about the mechanism to plausibly explain the underlying solar sunspot and solar polar field reversal cycles. So yeah, welcome to the Neo Renaissance. Congratulations on realizing the channel exists. Check it out. There's our latest post. And we'd like you to vote in our Twitter poll. So we put up a Twitter poll here. And you can also find our latest release there on Amazon Music, La Tour de Chance Speed. We'd like you to participate in this Twitter poll. If you're not on Twitter, get on Twitter. Why aren't you on Twitter? Don't get banned. Will you just continue to participate in medical safety theater perpetually? The choices are, I'm done, or keep masking. Next bonus feature is the ground-based solar observatory at El Teide, Spain. So you can see this filament eruption happening here. Some activity here ahead of Sunspot 2941. You can see a filament starting to move around there, looking like it's perhaps becoming ready to release. A bunch of filaments here in the earthly zone. I would call a coronal mass ejection watch or a warning. We stopped forecasting them because guess why? If it don't make dollars, it don't make sense. And it wasn't helping us in any reasonable way. So here are the sunspot groups. There's Sunspot 2942 in a setting mode. Sunspot 2939 there. Here's the latest sunspot group. It's Sunspot 2943, and it's grown since we did show prep. Here's 2940. And over here is 2941. These are all beta-class sunspot groups, folks. They're all capable of producing large flares. That is the most likely place to see a major flare. So keep an eye on it in 131 angstroms, 94 angstroms. Those are the best wavelengths to view solar flares from the SDO. So there's 2941's magnetic fields. Here's 2940's magnetic fields. There's 2942, that's beta class. 2940 is beta class. And 2943 to be named today. Again, has grown just in the past half hour. Continuing on to the NASA GOES 16 SUVI imagery. And if you're viewing smashandmash.com/smashteam's latest posts, you would have already seen this. Spectacular filament eruption there. There is a coronal mass ejection associated with it. Watch our previous videos if you want to see more information about that. We're going to close things out with the SDO, the same wavelength. So this is ionized helium, and so is this, at a higher resolution and a narrower field of view. So thanks for tuning into our bonus feature segment. Make sure you watch our previous daily space weather videos and our meteorology segment. We've been putting out 4 videos per day. Thanks everybody for tuning in, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.